What we're going to do now is go over Friday's assignment, because a couple of the classes that I was talking to the assignment about, they struggled with identifying these angles and then labeling the angles. So we're going to go over the assignment, and I'm going to use this highlighter in this software, and I think it allows you to see angles a lot better. So number 8 says 2 adjacent angles. When you hear the term adjacent, I want you to think of next to. So 2 angles that are next to each other. And anywhere in there, here's one right here. See it? That is CFG. CFG. And it is next to CFB. Alright? The yellow angle is next to the green angle. They are adjacent angles. There's more pairs of adjacent angles in the picture. DGE is adjacent to EGH, okay? Those 2 angles are adjacent. Adjacent angles share a vertex and they share a side. Got it? Number 9, acute and vertical angles. Acute vertical angles, that means they're less than 90. And vertical angles, they're opposite of each other. So right here, that's BFC and GFD. Vertical angles, and they asked for acute vertical angles. So they needed to be opposite of each other and less than 90. Those were 2 angles. 2 obtuse vertical angles. Obtuse vertical angles would be BFD and CFG. Very good. Those 2 angles are opposite of each other and they're greater than 90 degrees. Hopefully this is helping you see angles better. Number 11, complementary adjacent angles. Complementary adjacent angles. That means they're next to each other and they add up to 90. Complementary adjacent. Next to each other and they add up to 90. That's right here. FDG and GDE. I don't know what you guys are having a conversation about, but you shouldn't be talking. If you got a question, raise your hand. These are complementary adjacent. They sum 90 degrees and they're next to each other. Now the reason they sum 90 degrees is because all of these together form a line, don't they?
Yes.
And this angle is 90 degrees, which means this angle on the other side has to be 90 degrees. The green and the yellow together. So they add up to 90 and they're next to each other. Complementary non-adjacent. Complementary, which means they add up to 90. Non-adjacent, they're not next to each other. So that's this BCD and BAD. Those 2 angles add up to 90 and they're not next to each other. Next is supplementary and adjacent. Supplementary means they sum 180 and adjacent means they're next to each other. Supplementary adjacent is the same as a linear pair. So this angle here, BFC, and this angle next to it. They're next to each other and they sum 180. So BFD and BFC. And there's a bunch more in the picture, right? So those aren't the only ones. You've got this angle right here, FGH. and it's supplementary and adjacent to HGE. Those two angles next to each other, they form a line. Okay? A linear pair whose vertex is F. A linear pair whose vertex is F. So here's one angle whose vertex is F, and a linear pair means it's going to form a line with something, so right next to it. That's GFC and GFD. Those two angles form a line and their vertex is F. Again, there's more than one answer to that question as well. Number 15, an angle complementary to FDG. Complementary to FDG. What does complementary mean? They sum 90. So FDG, this is kind of a repeat question, because what do you got to add to it? Isn't this one added to it? GDE going to equal 90 degrees? Okay. Number 16, supplementary to CBF. Supplementary to CBF. So something that adds to CBF that forms or that equals 180 degrees. Well, doesn't this line form a 180? So CBF and FBA are supplementary. And then number 18 was supplementary to JAE. JAE is right here. And what's supplementary to that? DAB, good, right on the other side of it, DAB. That help, Jonah?
Yeah.
Better understanding of angle relationships now? Very good. Does anybody have any questions? Okay. Next thing we're going to do is go over a couple of examples on the top of 48 and the middle of 48, page 48. And here's the question that's asked. Find the measures of two supplementary angles. Find the measures of two supplementary angles whose difference is 18. Two supplementary angles whose difference is 18. Supplementary means sum 180. So we need two angles. So we got an angle plus another angle, and they have to equal 180 degrees. But the angles have to be 18 degrees different from each other. So let's call the first angle A. And if they have to have a difference of 18, what could the second angle be called? If one angle is A and the other angle is A plus 18, aren't they 18 different? Okay? If you got on the scale and then you got off and you picked up an 18-pound weight and you got back on the scale, aren't you going to weigh 18 pounds more? Alright? So this would be you getting on the scale plus you getting on the scale with 18 pounds. Alright? So now if you solve for a here, you get 2a plus 18 equals 180. And you can subtract 18 from each side. And your 2a equals 162. And you can divide by 2. So your a equals 81. If a is equal to 81, there's one of your angles, 81 degrees. And then if you take 18 and you add it to 81, it gives you the other angle, which is 99 degrees. Does that make sense to everybody? Alright, the second example is in the middle of page 48 where it says guided practice. And now we're going to find two complementary angles. Where the larger is 12 more than twice the smaller. Find two complementary angles where the larger is 12 more than twice the smaller. The first part of your setup's the same. You've got an angle plus another angle, right? And what do they have to equal? Now they're 90 because they're complementary. The first angle we can call A. The second angle is 12 more than twice the smaller.
2a plus 12.
2a plus 12, good. So now you can solve for A. So you got 3a plus 12 is equal to 90. And subtract 12. Divide by 3 and your A equals 26. So if your A equals 26, you can substitute. Your small angle is 26 degrees. And your larger angle is 2 times 26 plus 12. So that's 52 plus 12. 64. Alright, so those are your two angle measures. Any questions on either of those? Okay. Now I need you to look over at page 51. And we're just going to go through these and I'm going to show you how to set them up. The first 3 or 4 are pretty simple. Most of them are pretty simple actually. But I just want to make sure you can get them set up and then I'm going to let you finish them on your own. Got it? So right now, if you just continue in your notes, you're just going to have to copy these problems over on a separate sheet of paper. So right now, on a clean sheet of paper, I would start your assignment. Just do something like this. Page. It's going to be page 51. You're going to do 19 through 26. I'm going to show you how to set up the first 6. And I've already showed examples for problems 25 and 26. So just when you're writing these down on your paper, just leave plenty of room between the problems so you can go back and finish the work. Okay? So here's what number 19 is going to look like. The top angle is 120. The bottom angle is 2x minus 10. What kind of angles are those? Good, they're vertical angles. And vertical angles are congruent to each other. So this is a simple setup. Your 2x minus 10 is equal to your 120. Agreed? Now look, these vertical angles are equal to each other, and they're actually vertical of each other, right? But these angles that are left and right, these horizontal of each other, these two are equal to each other as well. The left and right are congruent. They're vertical angles. The top and bottom are vertical angles, and they're congruent as well. So they don't have to be stacked vertically to be vertical angles. They can be horizontal of each other. And they can be diagonal. If these two lines intersected here, alright, this angle would be congruent to this angle. They are vertical angles. And these guys would be congruent here and here. Okay? Good. Number 20. Looks about like this. On the left side you got a 12x. No you don't, you got a 2x. And on the right top you got a 4x plus 108. What is their relationship? They're supplementary. They're a linear pair, aren't they? So they have to sum 180. So your setup is that 2x plus 4x plus 108 equals 180. Combine your like terms and solve for x. Alright, now they're introducing a second variable. So you got 2x plus 25. You got a y. And then a 3x minus 10. Now when you set this problem up, you want to look at the expressions that have the same variable first. So your 2x plus 25 and your 3x minus 10, what kind of angles are they? They're vertical angles. So aren't they equal to each other? So your 2x plus 25 is equal to your 3x minus 10. And you can solve for x, right? Now, after you solve for x, do you see this pair of angles? What's their relationship? Those are supplementary, and they sum 180. So once you solve for x, can't you substitute it in this expression and get an angle measure here? And then that angle measure plus y equals 180. Okay? So it's like a two-step problem. Solve for the x first, and then substitute it and solve for the y. Alright, while we're at it, 23 is the same I think it's 22. 22 is the same concept. Might as well just get it on paper though. Here. You got a 3x, 8y minus 102, 2y plus 6. The expressions with the y's in them, what kind of angles are those? They're vertical angles. So these two are vertical angles. And they're congruent, aren't they? So 2y plus 6 is equal to 8y minus 102. After you solve for y, you can substitute, can't you? You can substitute for the y, and then what do these have to add up to? 180 again. So these are supplementary. When you substitute for the y, you can get a value for this angle, and then you're going to add that angle to 3x and make it equal to 180. Alright, 2 to go. 23 and 24. On the left side, you got 2y plus 50. And right below it, 5y minus 17. Upper right, 7x minus 248. And x plus 44. Alright, in this problem, these two angles are what? They're supplementary and they add up to 180, right? What about on the right hand side? Same thing. Those two angles add up to 180. Why wouldn't you use vertical angles here? Different variables, exactly. So use the expressions that have the same variable and the relationship that applies. Yes?
Can you just add them all up and equal to 360?
What would happen is you would have two different variables. You would end up with, 7y plus 8x plus a number. And your answer, if you solve for x, you would have a y in your answer, and vice versa. So pick a relationship where both angles have the same variable and solve for it that way. And then number 24. X plus 4, 14, 114, 2y, 3x minus 24. Alright, the easiest way to start this problem, these all intersect right there. Easiest way to start this problem is with your vertical angles. See them? Your 3x plus 4 and your 114 are equal to each other, aren't they? So there's where you start. Is it a 5?
Yes.
Sorry about that. So we'll change that to a 5. So your 5x plus 4 equals 114. That gives you your x, right?
Yeah.
Then, do you see these three? Right here. These three angles. Don't they all sum 180?
Yes.
Once you solve for x, you can substitute it here, where the x is. And you'll get a number, or an angle measure, for this angle, won't you? And then that angle, plus your 2y, plus your 114, will have to equal 180. And you can solve for y.
Would you plug the same x into the 5x plus 4?
You can, but if you did that, then you would use these. You could plug it in twice, but then you would use these three. And you would have to plug it in twice. Doing it the other way, you only have to plug it in once. Alright? Any questions? You're doing page 51, problems 19 through 26. Check your odds, please.